Hi dear children, we are here to learn chemistry today and I am Dr. Pinky Sharma presenting chemistry learning for you. Today we are going to study the chapter acid, base and salt for class 7. Do you know why we are using these acid, base and salt? Why we wanted to learn acid, base and salt? It is because we are coming across so many things in daily life which are either acidic in nature, basic in nature or neutral, or they are salts. In daily life you are coming across citric acid, you are using lemon, you are using oranges. So whether this acid you can eat or not, or if you are having some strong acid like HCl or H2SO4, so what are the uses of in this particular acids? Many other things like bases you are using, they are different soaps, detergents, chemicals, phenyl, Dettol you are using, all these are generally basic in nature. So you must know whether what is the nature of those particular objects you are using. So let us start the chapter acid, base and salt. Do you know what are the acids? These are the substances which are sour to taste. Their solutions are acidic. Now, another feature, how would you recognize whether this is acidic or not? You can, if you are not able to taste them, you can use litmus paper. How? Because litmus acids are known to turn blue litmus red. There are so many natural acids which are being presented in the daily life. You have seen it. You must know the composition of all them. For example, I would let you know you are using vinegar. This is your acetic acid. Similarly, you can see for the cold drinks. Cold drinks have carbonic acid. Lemon contains citric acid. Amla, the gooseberry, that is having ascorbic acid. Curd, it contains lactic acid. Tamarind, this is having tartaric acid. Similarly, the pulses have lot many amino acids. Now we have next, that is classification of acid. How do we classify acids? You have come across different acids. As I told you before, we are using different toilet cleaners. We are using some fruits also. Which acid is strong and which is your weaker one? Generally, the organic acids are very weak ones, which you are taking in your food items because it doesn't alter your pH of your stomach. Among these organic and natural acids these are generally mild acid which are found in natural substances like fruits, curd and pulses. For example, you are having lactic acid, citric acid, acetic acid and ascorbic acids. So these are organic acids which are naturally found in living beings. Living beings it includes fruit because plants it is already living. These are non-corrosive and do not burn skin. Non-corrosive means this doesn't burn your skin. They are very mild. Next is another category is mineral, organic. Either it is, we can call them mineral acid, we can call them inorganic acid, we can also call them artificial acids or synthetic acids. These are the strong acids synthesized in the lab. For example, in your labs, you might have seen HCl, you might have seen hydrosulfuric acid, you might have seen nitric acid. Another feature, how would you distinguish between them? These are highly corrosive in nature. Corrosive means simply they burn your skin, as in when you are in touch with them, your skin get burnt. Example of this, you all have seen in your laboratory. These are hydrochloric acid, sulfuric acid and nitric acid. Now the most important, we'll come across properties of acids. Properties of acids, how would we know whether these acids possesses what character? For example, first we have acids are sour in taste. Next is they are generally soluble in water. Third and most important property is they conduct electricity. Next is they are generally corrosive in nature. Children, another thing is they cannot be stored in metallic container. Fine. So in later classes you will be able to know why it happens so and how it happens so, which is the extension of this syllabus, that is called displacement reaction. We'll come across in higher classes. In the sidewise you can see the bar which is showing you the pH. pH is, for you to understand at this level, is simply the increasing order of acidic character. We are moving from mild to higher one. If we come down, we are seeing the first one, pH 14, which is your liquid drain cleaner, which is having the mild pH like 14. Next is bleacher over cleaner. Next you can see ammonia solution, then baking soda. Baking soda you are able to see it is coming at next level. Baking soda we can also use it for your gut. You can take it for your eating purpose also. Then sea water, then blood having the pH 7.4, milk, black coffee, grapefruit juice, and as we are coming down, it is the pH value is getting lower. That means acidic character is increasing more and more. Grapefruit juice is sour, having the less pH but more acidic character. Then lemon juice, still more acidic, and among this property of acid you can simply see the strength. We are moving from, next will come bases. Children, now we are going to start bases. What are bases? Have you seen in your daily life? Did you know what are the bases? Yes. So now we are going to explore what bases are. The bases are the substance you are coming across in your daily life which are very much bitter in taste. Have you seen soap? Yes. You have seen different cleansers also at your home. You have seen shampoo bottles. All these are basic in nature. These are the substances which are bitter to taste and their solutions are basic in nature. Second important point is bases are known to turn red litmus solution or paper to blue. Now what are the commonly found bases in which we are using in daily life? The first is baking soda. What is the name of this base? That is sodium bicarbonate. Children, this is the naturally occurring base. Where other way we are using it? In baking cakes, there also we are using baking soda. Next is lime water. Something we are using, white colored stone, we are in your home, whenever it is being done, it becomes hot and the bubbles comes out. So there, what is that? That is simply calcium hydroxide, and the name of this compound is lime water. This is also occurring in natural form. Then next is soap and detergents. So the soaps and detergent, they contains sodium hydroxide, they contains potassium hydroxide. So these are some commonly found bases. Another example, did you know what is the constituent of window cleaner? This is simply an ammonium hydroxide, dear children. It is the time to learn. This is ammonium hydroxide which is being used in window pane cleaner. Another one base where we are using, just I have told you, one was sodium bicarbonate, another antacid is milk of magnesia. By now you have known it. What are the antacids? Antacids means which are acting against acidic compounds. Okay, dear children, can you see the pictures? I have given here the different pictures. What are those? Those are soaps and detergent which you are coming across in your daily life for the cleaning purpose. Okay, so these are just to know that we are dealing with basic compounds. So next one, we'll move towards classification. Bases can be of different strength. How powerful, strong a base is, depending on this we had classified the bases into two categories. These ones are weak bases and strong bases. How would we distinguish between strong bases and weak bases? The strong bases are highly corrosive in nature. They may cause skin burns. Highly corrosive like sodium hydroxide. If you can see, when we are taking bath, we should use Pear soap, and different brands we are using. Can't we use the same soap for every purpose? Because they are corrosive in nature. When we are dealing with bases, in the bathing soap, the corrosiveness is mild. So we are using weaker bases over there. Okay. For cleaning the utensils, for cleaning the clothes, we are using strong bases. So these are highly corrosive in nature, may cause skin burns. For example, you have sodium hydroxide and potassium hydroxide, which is a very important constituent of all your soaps and detergents. Next category is weaker bases. What are the weak bases? These are the mild bases which do not harm the skin. For example, you are rather eating sodium bicarbonate. Sodium bicarbonate is a very mild base. We can even drink it in the form of antacid. We are also eating magnesium hydroxide, that is milk of magnesia, for the antacid purpose. Now we are switching to properties of bases. Let us start one by one. The first thing we have known by now, the bases, how to identify. Bases are generally bitter in taste. Like you have different soda, sodium bicarbonate, eating soda, or if you are using this one milk of magnesia, these all are bitter in taste. These are slippery to touch. Have you ever seen the soap? Soap, when they are wet, they slip out of your hands. So this you can see the another properties they are. Similarly, the baking soda. The few bases next is solubility, whether they are soluble in water or not. How could we check? As you have seen some of the mild acids like sodium bicarbonate. So there are few bases which are soluble in water, but it is not true for all, like acids. Okay, this is not true for all. For some of the bases are there which are not soluble even in the water. Next is the bases also conduct electricity in the solution. As we children, we have just read in the case of acid, the property of acid, that acid conduct electricity. Why? Because they have ions. Similarly, like that of acid, the only property they are matching with the acid is they are also conducting electricity in the solution. Obviously, when they are being dissolved in water, then only their ion will be separated and they will be conducting the electricity. Dear children, by now we have read what are acid and what are bases. Now there is one very interesting phenomena, that is indicator. How do we know whether a compound is acidic or basic? Can it be known through taste? Not always. We cannot taste all acid and base. So we have the category of indicators, a series of indicators which are going to tell you whether a compound is acidic or base. You can know it without tasting them. So what are the indicators? They do tell us whether a compound is acidic, basic or neutral. So there is two category of indicators out of these. This is natural indicators, that means which is occurring in nature simply. That is not man-made. The natural indicator contains, the first and foremost is litmus. Litmus is a dye. It gives color and gives different color with acid and base and indicate whether a solution is neutral, acidic or basic. Another dye we are using daily in our life is turmeric. Turmeric is a dye having yellow color. This also indicates basic character. Similarly, we can also use China rose solution, that is also acting as a very natural indicator. Similarly, red cabbage. Red cabbage is also having red color pigment which is turning color in acid and base medium. Another category of indicator is we are having synthetic indicators. Synthetic indicator contains phenolphthalein and methyl orange. The first one is phenolphthalein, which is a colorless compound which changes its color with base. Similarly, we have methyl orange. This is a orange color dye which give different color with acid and base. We will checking in the different activities. We will show you how the litmus turns indicates the acidic and basic character of a particular compound. So, here are 3 samples I will show you. This is the compound A. I don't know what is the nature of this compound. This is B. I don't know whether it is acidic or basic, and another one is C. That means 3 samples are unknown to me. My objective is to identify which one is acid, base or a neutral compound. So, for this, as I told you, we can use litmus as an indicator. One by one I will check it through the litmus paper. The first is red litmus paper, and as already described, red litmus is used to change or to check the nature of your compound. So, if I will put this red litmus paper into solution A, let us see what happens. This is unchanged. There is no change in red litmus paper. This indicates that is the compound given is not basic in nature. Now, we will see the another one, that is blue. This blue paper, I am dipping it into compound A. Now, can you see the change? It is the blue color paper is, as soon as it is being dipped, this has turned into red color. So, this clearly indicates the compound A is your acidic compound, because it has turned blue litmus paper into red one. Now, let us start the same activity with the compound B. So, first we will put this red litmus paper into compound B. Oh, you can visibly see the change in color. It has turned from red to blue. Children, what does it indicate? It indicates this is turning red litmus paper into blue. That simply says it is your basic compound, which is turning red litmus into blue color. Now, it's not needed that I should check it through the another paper. So, my objective is clear here. The compound B is basic in nature. Now, next is C. The sample C, I will do the same activity. Now, I am using this red litmus paper. Let us see what happens. Children, see, there is no change. Now, the same thing I will be repeating it with blue litmus paper. Are you able to observe any change? Do you notice any change? No. That simply says this compound is neither acidic nor basic but neutral. Now, I will show you further one activity which you can use at your homes also. Children, these were with acid and base in particular. You have lemons at your house. Lemon, you all know this is sour in taste, and obviously you can check at your home. You can take simple juice of lemon and repeat this activity I have done previously. Okay. So, first what I will do, I will put red litmus paper into this solution. Is there any change? No, because it is already, you know, it is acidic, but just to confirm you can check it through these strips. Now, I am putting another one, that is blue paper. Can you see? Oh, amazing. So, this has immediately turned into red one. Okay. So, this clearly show at your home that your compound is acidic in nature. Now, there is one more indicator I will show you here, that is turmeric. How do it indicates? We will see it further. So, at your home you can easily check some basic compound which will be indicated by use of turmeric. Now, I have taken here a white cloth which has been stained due to turmeric. So, it is yellow in color, you can see it nicely. Now, I had used in another bowl, I had this soap cake. So, this is washing soap. So, detergent and soaps are basic in nature. So, you can confirm it through these two things. So, this the stained cloth, I am putting some soap over it and you can see the change. How does it change? On a very first touch only, it is showing you the red color, which is clearly indicating the basic nature of this soap bar. Now another category is synthetic indicator. We are here to see the synthetic indicator. The next we are doing is synthetic indicator. We have studied about two synthetic indicators. The one is your methyl orange and another one is your colorless solution of phenolphthalein. Now we are going to see what happens when we treat these with acid and base. How did they indicate? So let us see the methyl orange first. You can easily see the orange color of this dye. Now in this test tube, I am taking hydrochloric acid, that is, which is acidic in nature. Now you can see what happens when methyl orange drop is being put into acids. Please observe the change, dear children. Wow! Isn't it amazing? This orange color dye is turning red, bright red continuously. So this is indicating the acidic nature of this compound. That is, orange color turns to red when an acid reacts with it. So the methyl orange turns acid to red. Similarly, we can look it for the base. I have another compound, that is sodium hydroxide here. You can see this. When we are putting it, this is NaOH, that is a base. Now let us see what happens when we are putting methyl orange into this. Okay. Let us see. Now see, wow, amazingly it has turned to yellow. So what does it indicate, dear children? The methyl orange turns to yellow color when it is being treated with base. So this is your synthetic indicator, which also confirms which is your acidic compound and which is your basic compound. Fine. The last but not the least, I will show you another synthetic indicator, that is phenolphthalein. Phenolphthalein is used to check whether the compound is basic in nature or not. I will show you one activity. This is your phenolphthalein, which is colorless. Now what is the base here? I have taken this base, sodium hydroxide here as a base. You can see the color. Now I will put few drops of phenolphthalein in this. Dear children, you can see it has directly turned into deep magenta pink color, that is magenta color, which indicates that phenolphthalein is an indicator which confirms the basic nature of a compound. So this was all about synthetic indicator. These activities you can do at your labs anytime very easily, but under the supervision of your teacher. What is neutralization reaction? Neutralization reaction is the reaction between an acid and a base, which results into salt. That is how the salts are formed, that I am going to show you through one simple activity, that is neutralization reaction. So we have here the two compounds which are required for neutralization reaction, that is one acid, that is hydrochloric acid, and one base, that is sodium hydroxide. So you know neutralization reaction is the reaction between these two antagonistic compounds. So in this beaker I am going to pour some of the HCl first. So in this beaker you can see I am pouring HCl. You can put around 20 ml, and similarly we can add another compound, that is sodium hydroxide. So I am adding it here. So you can see the bubbles coming out. Are you able to see these bubbles coming out? These effervescence, this is clearly showing that some neutralization reaction is going to take place. And how you can check? this is being exothermic reaction. You can check the temperature of this. See, this is rapidly rising. The temperature of this is being continuously rising with the happening of this reaction. So this is, dear children, this is neutralization reaction, that is how to make salt, but the salt will not appear immediately. You know why? Because in the neutralization reaction, the product of this is water and salt, but the salt appears very slowly with the passing of time, because crystallization process occurs at very low temperature. So as it will cool down slowly, you can see the changes and you can see the crystals of the salt, which is one I have taken hydrochloric acid and I have taken sodium hydroxide. So what will be the salt appearing here? This would be sodium chloride. But dear children, immediately you cannot see. We'll cool it and we'll see after few hours it will be giving the crystals of sodium chloride salt. This you can learn in your labs as and when your teacher and you are convenient. Thank you. I hope you like the activity. Thank you so much. So dear children, today in our class we have studied about the concept acid, base and salts. We have learnt about what are the acid, base and salt, what are their common properties and how they can be differentiated and identified by using different indicators, the natural as well as synthetic indicator. With this, I am leaving you all with the concept to learn more and more about the concept acid, base and salt, and also to explore this and imbibe this knowledge while performing your daily life activities. That is, the product you are using, what strength, what acidic character, basic character, how strong and how weak the acid and base are and where you can use them. Thank you.